Hello, my name is Sophia Shen. I'm a trainer from SAS. I did a webinar on machine learning using SAS Viya. I hope you enjoy a short extract from that webinar. Thank you. Bye. In Model Studio, you can see the nodes, the different models you can build in different groups. So under the supervised learning group, you can see there are a lot more models here. So there's the quantile regression model and the Bayesian network models is also here. You can also use batch code and score code import to import the enterprise minor models into Model Studio if you have enterprise minor models. So Model Studio provides a more supervised and unsupervised learning models. You can also do semi-supervised learning models too. Okay, so you can also use the SAS code node and open source code node to build models using Python or R or SAS code. So in Model Studio, you can build 3 types of models. If you have time series data, then you can build forecasting models. And if you want to analyze your unstructured text, then you can build the text analytics models. But I'm going to concentrate on the data mining and machine learning models. So this is a model pipeline, or in the SAS9 enterprise mining world, we call this the process flow. So each of these purple nodes, they are the supervised learning models. So you use these different nodes to build a flow that can do more than just the models. Before you build the models, you can also do some pre-data processing tasks. And then it's very easy for you to compare different models here too. So talking about machine learning models and algorithms, here is a list of some common algorithms and their use cases divided into different domains. So I guess if you are in risk management, you probably will be interested in the PD models. If you are in marketing, then churn models, might be of interest to you, or the PDB models. So, and in the fraud space, you can build models to detect the suspicious transactions or claims that looks a bit strange. Okay, and you see a lot of the frequently used models being used for these different situations. Okay, you can see the logistic regression model still listed here. The regression model is one of the oldest models. In fact, the SAS procedure proc logistic, it's dated back in the 1980s. So they have this procedure 40, 50 years ago. And banks still using the logistic regression extensively and often prefer it over other type of machine learning models. And the reason is that it's very simple, it's very stable, it's computationally light, and it's quite fast to train. Okay, we call models like decision tree and the logistic regression models the white box models, because you can explain the results, and this ability to be able to explain why you get the output is very, very important, especially for regulated industry such as banks. You also have other type of models like the neural networks and the random forest and gradient boosting models. These are what we call black box models. So sometimes you'll also hear the term opaque models. So these models that you can see, they are a black box. So they might be very powerful, but the results from these models are not easily understood, and it's hard to explain. Okay, so which machine learning models should you use for your business problems? that really depends on your requirements. There's no single recipe here. So some of the things you should think about is what is the size and the nature of your data? What's your goal of your project? Do you need the results to be very accurate? If you get the prediction wrong, what's the cost of that? And do you have time to train your models? Or do you want a model that can score fast? And do you want to be able to explain your models? Or are there any regulatory requirements you need to think about? Yeah, so to summarize, there's really no one model that's always the perfect one to use, and you should try different ones. So here you see a nice table of the common algorithms and some properties of them and the concern. So if you have extremely large data, maybe you want to think about the Bayesian network. If your data has a lot of missing values, then maybe the tree models are a good one to use, because tree models can handle missing values.